All right, so let's add up all the forces on A here. Okay, so let's first off find the magnitudes, right? Okay, so to find the magnitudes, the force of C on A is K Q Q over R squared. So that's going to be 8.99 E9. C is 153. E minus 6, that's microcoulombs is what that says, right? And A is 16 E minus 6 coulombs, right? Come on, maybe I'm going sideways. There it is, okay. And then our distance is, well, that distance there, we have to use the distance CA, right? Is equal to the square root of 0.75 squared plus 0.75 squared. Okay, so we're going to use the distance formula, right? Now, notice that it's r squared, and so we're ultimately going to square a square root, right? So I'll just write that, but from now on I kind of don't, you know. Yeah, there it is. It's so reluctant. 0.75 squared plus 0.75 squared. And then, of course, this whole thing is squared, right? So the square root goes away, right? Okay, I don't even need to do it. So I'm going to go on, I'm going to go alpha F1 and get that first fraction. And I'll go 8.99 E9 times 153 E minus 6 times 16 E minus 6. Okay, do I have that? I do have that, okay. And then in the denominator, I've got 0.75 squared plus 0.75 squared. Okay, so this is 19.56224, and this is this way, right? This forces, right? So it's at a 45-degree angle, 45 degrees up and right. Okay, up and right. And when I say 45 degrees, I always find, my habit is I always find the angle with the x-axis. That's pretty handy. Okay, so let's see. Pointer options, okay. All right, so now let's find the force of B on A. Force of B on A, which is of course going to be KQQ over R squared. Right, so that's going to be, it really doesn't want me to draw lines that way. 8.99 E9, let's see, B is 312. And A is 16. And then let's see, our distance here is 1.9 meters. And then that's also 0.75. That's a congruency thing. So this is 0.75 meters as well, right? So this will be 1.9 squared plus 0.75 squared. Okay. Now really it's the square root of this, the whole thing squared, right? Just like that, but I'm getting lazy, so let's do this. Okay, so I go up there, boom. And let's change one of these to 1.9. I'm just editing the fun thing I did before because it was so beautiful. Okay, and then the 16 stays the same, but the 153 is a 312 now. Okay, so I get 10.75568. 10.756, I guess is what we say. 557, there we go. And that's newtons of force. And then, this is tough. So let's see. That force is, notice that this is a positive charge. They're all positive charges, so they're all repelling, right? So that force is this way. Let's see if I can draw it accurately. Right, and that angle there is the same as this angle. Right, and that angle there is tan minus 1 of 0.75 over 1.9. Okay, by the way, you can do this without angles at all. So let's see, the second tan of 0.75 divided by 1.9. So that angle is 21.54. Okay. Okay, let's partition off this space. These take up a lot of space. Okay, so this is up and left. Okay, it's up and left, and it's 21.54 degrees above the x-axis, right? All right. So we've got the magnitude of the forces, right? And we've got the direction, right? This is up and left, 21.54 degrees. This one's up and right, 45 degrees above the x-axis, right? So now let's just set up our components, right? We've got FCA, right? And we want to figure out what it is. There we go. We got this. There we go. Okay, so FBA, and then this is the sum, right, of this. And then here's the x direction, and here's the y direction. So let's divide this up, right? So now how do we do this, right? Well, FCA is up and right, so this is going to be positive x, right, and positive y. It's up and to the right. And it's going to be, I guess I'm going to do 19.56, and we're going to go cos 45 degrees. All right, so let's do that. 19.56, that guy, cos 45, and that's 13.83. 13.83, and then this will be 19.56 sine 45. Of course, that's the same thing, right? That'll be 13.83. So now we've got the x and y components, right? So this is x hat, this is y hat, right? Let's do FBA, okay? This guy is going to be to the left. This x component will be this way. And then the y component will be this way. Okay, so this will be a negative. And what is it going to be? It's going to be 10.7557, so I'll go 10.76. And then it'll be cos of 21.54. Right? So let's do that. Let's grab that number. So I'm just grabbing these numbers. That number, cos of that angle. All right, so I've got the x component, right, is negative 10.004, right? And then I'm going to calculate the y component. Okay, so this is going to be 10.76 sine of 21.54. Right, so let's go. I'm going to go grab that number. Actually, I'm just going to grab. I'm making a video right now, so I'll talk to him later, I guess. All right, so I grab this guy here, and then I go boop, 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 and I go sine of 21.54, and I get 3.949. There we go. And now we can just add these guys together, right? So 13.833 minus this 10.04. And I'm using the up arrow on my calculator. I'm using these unrounded values. This ends up being 3.828 newtons in the x direction, right? And then I'm going to add these guys together, so the 13 point whatever, that guy, plus the 3.949. And that's going to be 17.78. And that's newtons in the y direction. All right, so now we're good. Now we're almost there, right? Okay, so let's draw a picture of this guy, right? So I'm going to go to the right, 3-point that, right? And then I'm going to go up. And then the vector is this guy, right? Whoa, it's so hard to draw a straight line, right? Okay, so that angle right there is, tan minus 1 of 17.78 over 3.828. So second tan, that guy, divided by that guy, 77.9 degrees. And then the magnitude of this will be the square root of, it'll be the square root of 3.828 squared plus 17.78 squared. Okay, so square root of squared plus that guy squared is 18.2. So this is how we know we've got the right answer, right? I've labeled this angle 77.9 degrees. I've drawn a picture of the vector as an arrow. I've labeled which angle I'm finding, right? I've labeled the magnitude of this with what it is and what the angle is, right? Okay, so those are the steps, right? Step 1, find the forces. Step 2, find the angle, some angle, right? I always find the angle with the x-axis like that, just because then cos always gives you like the x component, sine the y. But you do have to be careful. Like, for example, this component was to the left. This is up and to the left. This is up and to the right. Helps me to write this down, to write up and right, left, up and left. Okay? Then you break it into components. At this point, you should reflect, does this make sense that it's a lot to the left, a little bit up? Yeah, that does make sense. Is it a lot to the right and a lot up? Yeah, that makes sense, right? Then add it up and then draw a picture of it. Happy hunting.